for proposal for Venture Class Launch Services. And to discuss the Venture Class Launch Service opportunity today is Mark Weiss, the Chief of the Flight Projects Branch for NASA Launch Services Program Business Office at the Kennedy Space Center, and Garrett Scrobot, the Alana Mission Manager for the Launch Services Program, also at the Kennedy Space Center. And we'll begin first with Mark Weiss. Mark?
Thank you, George. So appreciate everybody dialing in, listening in. We wanted to take the opportunity today to explain this requirement a little bit and talk about what LSP does and why we're doing this. So the Launch Service Program here at Kennedy, we provide the leadership and expertise providing on-orbit, on-time, and on-cost launch services for the agency's science and exploration spacecraft. So we've been greater than 75 missions, launching those things that help study our planet, looking at Mars, the Curiosity rovers, or even Pluto with the New Horizons spacecraft that's on its way today, launching back in 2006. So we're a commercial launch broker for the agency. So just as a real estate agent helps you navigate buying, selling a home, we're there to help navigate through that complex rocket science business, helping payloads get into orbit. So that expertise that we provide helps mitigate the launch risks and helps assure mission success for our customers. So traditionally, access to low Earth orbit has been government driven. We see that starting to change the commercial market, obviously, with things like Commercial Crew here at Kennedy. But the costs are still pretty high, and a lot of our science community has been looking to find ways to get things that are more affordable, and we've seen spacecraft sizes starting to drop, and we've got Garrett here also to help talk a little bit about the CubeSats and how smaller satellites have started to evolve over the recent history. So this VCLS requirement is us trying to help open that door. We're seeing these requirements come a little closer to something that we'd like to provide. We see the commercial market evolving. So we've been working over the past couple of years via strategic initiatives to try to help open the door for these more affordable launches. And with VCLS, we're looking to be one of the first customers to the many companies trying to bring a product to market, quickly trying to be the first one. And we want to be that first customer, help mentor these companies, and help get these small satellites onto orbit.
Thank you, Mark. Now to Garrett Scrobot, our Alana Mission Manager from the Launch Services Program. Garrett?
Yeah, thank you, George. Thanks, everybody, for tuning in. Just going to give you a little brief on where we were at with our Alana missions, educational launch of nanosatellites. These missions are developed out of the NASA CubeSat Launch Initiative, which headquarters manages to provide opportunities for educational, nonprofit, or government entity CubeSats to go fly piggyback on our current missions that we have. Over the last 3 years or so, 4 years, we've launched about 36 of these type of CubeSat missions from various universities, entities. And we're looking more to the future on these CubeSats over the next 3 years. I have about 50 missions on backlog that's going to be ready at various times, and we're looking to be able to find more of a dedicated ride for some of these missions that are having more complex science. When we piggyback the CubeSat, or what we call it now a U-class payload, is the form factor. U-class payload is more of a form factor of the cube, a 10 by 10 by 10 centimeter. Now we're getting into longer, bigger types of forms, and so we're looking at this U-class where it could be 6 U's or 12 U's in size. They are requiring not to be piggybacks anymore, not to go where the primary is going, but to identify particular orbits where they can do scientific experiments on their own and get more data science. So what this Venture Class Launch Service is going to do for us is going to help us in the arena of potentially taking some of our science missions and putting them in positions over the Earth so they can monitor the weather patterns of the Earth multiple times over revolutions, to look at our hurricane systems, or CubeSats that want to look out into the dark elevations of black holes and look at X-ray, gamma rays, and stuff like that. They need particular orbits to fulfill their mission in their orbit, and so with this they'll be able to call up a launch service and be able to go where they need to go to do their missions.
All right, I think we'd like to take some questions from the news media. And Miriam Kramer, I believe you are first up. If you'd like to go ahead and ask your question, and if you'd address it either to Mark Weiss or Garrett Scrobot. Technical issue. All right, while we're trying to work that technical issue out with Miriam, James Dean from Florida Today, do you have a question? Stephen Clark, are you on the line? Go ahead with your question.
I can't.
Go ahead with your question. All right, while we're waiting to work out the technical issue, let's go ahead and talk here a little bit about it. Yeah.
While we're working through it, just give a little more about what we're trying to do here. So we structured this VCLS contract with a high risk tolerant approach. So again, Garrett mentioned we've got this backlog of CubeSats that we're looking at over the next few years to try to help get more rides, get them more access to low Earth orbit. We're also trying to be that risk mitigation for future science requirements. So the Science Mission Director is one of our largest customers at NASA headquarters. Again, studying our Earth. They have some small payloads in the future that they're looking at potentially utilizing a capability such as this to help get the launch cost into a more affordable range. As we drive the cost down, that helps more money be freed up for science. So they are always looking for opportunities to get to space at a lower rate. That then again turns to them having greater science requirements that they can do missions more often, take advantage of technology changes that happen quicker, so that spacecrafts that are in design 10 years out, they can maybe turn that around quicker and have the latest technology going onto orbit.
I think we have Miriam Kramer back on the line. Miriam, you want to go ahead and try to ask your question?
Hi, yeah, this is Miriam with Mashable. Can you guys hear me?
Yes, we can hear you.
Okay. Great. So I'm curious, you sort of went into this a little bit. I think this question is for Garrett. I'm just curious if you can explain some of the benefits of these tiny satellites, kind of when compared to larger satellites. So aside from cost, are there things that these satellites can do that maybe you wouldn't be able to do with a larger mission? Thank you.
The CubeSat market, or the CubeSat, basically was developed from Bob Twiggs when he was at Stanford University back in 1998, I believe. And what he did, he challenged his students. He took a Beanie Baby box. Remember the old Beanie Babies? It was a 10 by 10 or 4-inch square cube. And told the students, if you could put a satellite in this box, could you do something positive with it or very good? So, the kids took it, they started working with it, and when you start getting bounded by a specific requirement to say, stay within this box. You can do anything you want in the box, but stay within the box. Everybody starts creating new ideas on becoming smaller and smaller and smaller to get more stuff into the box, and you got to be at 1 kilogram. So what drove this is a lot of the micro technologies with spacecraft today helping out. These kids, they developed, designed new boards to make everything a lot smaller. I've seen RF transmitters the size of a 1-inch square board is now an RF transmitter. So what can be done with these, the other big spacecraft? Well, these are good technology demonstrations for big spacecraft. One of the missions we flew was M-Cubed out of JPL in Michigan. It had a Vertex 5 processor chip on it, which needed time on space to verify the processing on orbit before you put it in one of the big Earth-Decadal satellites. So it helps the technology, proves the technology, get the TRL levels up for bigger, larger spacecraft. Then you start looking at some of the big spacecraft and say, okay, well, there's multiple instruments on it. Can some of these instruments get smaller because the other technology is getting smaller and they can fly these instruments in a smaller package? And that's what they're trying to do today, and look at how Earth's observation sensors, deep space sensors can now become smaller and do some of the work that some of these larger spacecraft have done in the past.
A lot of our spacecraft today, if you start designing a new requirement, it's the technology that you put on paper today for a large spacecraft is going to take 7 to 10 years before it actually flies. Some of these smaller ones, that turnaround time is much quicker. So you start designing something today, you might be able to get it in orbit next year. And the advantage of smaller is you can put more of them up in the same orbit and collect that data point over and over and over again as time changes. Today, if we've got an Earth-observing satellite that's in a sun-synchronous orbit, it's looking at the Earth every point once a day. If we go up with these smaller satellites and you put a constellation up there, you can now look at the same point every hour, every minute, which starts to open up new commercial entities. And that's why I think you see a lot of these commercial companies starting to find viable business cases. The explosion of data in today's society, the need to connect people, connect products, connect cultures in new ways in real time, this is what this will open up for us.
And to follow up on that, one of the missions that we just awarded or is now going to be added to the InSight mission is called MARCO, which is Mars Cube 1, which is a 2.6U spacecraft that's going to fly by Mars at the time that InSight does its descent into the Martian atmosphere, and it's going to transmit the data back real time to the Earth while the spacecraft is going into the atmosphere. So now we're taking these small spacecraft, making communication systems out of them, and going to other planets with them.
Miriam, do you have a follow-up? Or
that's it for me. Thank you.
All right, thank you. All right, Stephen Clark from SpaceflightNow.com. Stephen?
Hi, George. Thanks. Just a couple of questions for me. How much overlap or how much synergy do you see between this Venture Class Launch Services draft RFP and some things some other government agencies like DARPA are doing to try to develop small dedicated launch services or launchers? And also for the Alana program, can you give me a little background about how the funding for that works and how much it costs to launch a typical CubeSat, perhaps? Thanks.
Maybe I'll start with the
DARPA
one and let you hit the backhand. So DARPA is doing things that is more. They started out, I think, technology focused. They've got bigger picture to get satellites to orbit at a very low cost. And what they've been doing is more from a developmental standpoint, developmental contracts for the government to help grow the technology to be able to escape Earth's gravity pull and get very small payloads up there. So we've kind of leveraged off of some of that. Some of the technologies that have been developed as a result of DARPA have opened the door for some of these commercial companies that are racing to try to be the first ones to have a viable solution to get there. We collaborate constantly across the government with DoD, the NRO. We're constantly looking at other agencies that are doing technology to get things into orbit. So although this contract isn't directly tied to that, there's definitely a benefit, and that's why I think we're looking at a sweet spot of where we're at today, that we see companies ready to bring a commercial solution.
And then when we get into costing for launch, there's other launch companies out there, commercial brokers that are offering rides, piggyback rides with other commercial missions. And we're seeing a price range in anywhere from $250 to $500K per a 3U system for launch. There is a lot of synergy between the government agencies. I work with the NRO, ORS, and sharing ride space between the organizations to try to get our spacecraft launched and their spacecraft launched in a more synergetic fashion and cost effectiveness.
All right, we have a question from Mark Rowe from Aviation Week in Space Technology. Mark?
Yes, thank you very much. I have a couple of questions. Reading your draft RFP, you talk about a single 60-kilogram payload or two 30-kilogram payloads, if I read that right. Can you kind of explain your thinking on offering that up for comment for a demonstration mission? And then I have a follow-up, please.
So last summer, we put out a request for information called Next XL. So that was us looking at, Next was a contract we did back in 2013, stood for NLS, NASA Launch Services, Enabling Exploration and Technology. We went out with the XL requirement last summer, XL just being extra large, trying to grow that requirement. During Next XL, we surveyed the market and looked at what capabilities they were developing. What did they see as the viable business case? Because again, launching just NASA payloads probably isn't gonna close the loop for you to make money. It's going to be the commercial marketplace as well as us. So we wanted to see what these commercial companies were doing out there. What did they see as the best fit rocket design? So the data we received from that helped shape VCLS, and that's the requirement we ended up putting out. So we listed it as 60 kilograms with one launch, or you could do it within two launches, 30 kilograms each. That was so we could get maximum width, kind of widespread this requirement and make sure multiple companies had a chance at bidding on this. They're all coming at it, from different angles, different costs. There may be a cost benefit to one company's solution to do it in two flights versus just somebody doing it in one. So we wanted to make sure we threw a wide net out there and gave the opportunity to as many of the companies that are trying to be the first to get out.
For my follow-up, and I guess it's an A and B part of my follow-up too, but for the mission you envisioned in April of 2018, do they all have to be orbital? If they can develop it right, could it be lunar or interplanetary or some mix? And then I just wonder where you see this going if your 2018 mission is successful. Would NASA conceivably come back and contract for a larger larger group of missions?
So the requirement out there in 2019, towards the end of this decade, the customer has expressed to us the potential to break, like Garrett mentioned earlier, breaking out instruments onto multiple spacecraft so that they could be lifted via small payloads. So that requirement, again, we're trying to find a way to get to orbit at a lower cost. If that was successful, if VCLS works and we're able to contract and bring that type of a requirement to our customer in 2019, and that's successful, at this price point, I definitely think the science community is going to continue to try to take advantage of this. We've got payloads on contract today, that are smaller spacecraft, in a constellation setup. So if you could break them apart and launch them via something like this, that's where you start to look at the cost trade. And then I think as you start to go beyond Earth orbit, I think Garrett is the one that's starting to see that with the cubes, and you see it with Marco that he mentioned before on the InSight mission. So as stuff like that starts to happen, as you start to see, these newer generations of Earth science, space science, guys coming out of college trying to find innovative ways to put spacecraft in these smaller boxes, I think you're going to see more of it at this type of a price point.
Yeah, I think part of this is a demonstration flight. And what we did is identify a good altitude to demonstrate the capability, the 425 that's in the RFP, and also the altitude, the inclination between 38 and 98 fits into where I have plenty of U-class payloads or CubeSats that want to go fly in that arena. Now, depending on the vehicle class, what could they do to an orbital injection? That depends on the vehicle class itself. They may only do 5 kilograms to lunar orbit or something like that. And if they could do that, we may take opportunities and take advantage of that. But right now, we want to get this demonstration one out of the way and then work from that point on to see how we can use this in the future.
So the demo is primarily orbital, and then you'll go from there.
Yes.
Yes. And I do have other cubes on the list that would want an Earth escape mission.
All right, James Dean from Florida Today.
Thanks, George. Can you hear me okay?
Yes.
Yeah. Okay, thanks so much. So, guys, sorry if I missed this, if it's in the RFP, but just a couple of basics here. What's the funding for this program? Is it an annual amount or recurring? And do you have like a number of partners you anticipate signing up, or is there any limit to that?
So we haven't disclosed the funding amount. It's not an annual requirement. This is a strategic investment we're making. So the reason we haven't disclosed it is because price is obviously a big driver in our competition. So we want to make sure that, again, we're trying to buy a commercial solution. So we want these companies to have a commercial viable business case, and we want to be able to take a part of that. We're not looking to develop a system necessarily. This isn't a government-funded development situation. So we're trying to keep that point, keep that dollar amount as something that's not out there and visible, because we want to see what they can bring to the table. The plan is to award more than one. So again, it's all funding dependent. So as we see what proposals come in and we go through our evaluation process as documented in the RFP, then we'll see where this takes us.
Okay, thanks. And maybe just a few quick follow-ups. You mentioned, Garrett, I guess the price, the approximate price you're currently paying to piggyback, and obviously you're trying to get a more affordable ride. I mean, without being more specific than you want to be, can you give a sense of what your sort of target ideal price range would be that you're trying to get this thing down to? And then I was wondering if you might, again, without sort of predicting who's gonna respond, could you give any sense of companies that are in this class that want to do this? Are we basically leveraging systems that are already well into development, or talking about designing something entirely new, and also would you see that as more likely this being a vertical or horizontal capability?
Well, from a budget perspective, budgets are always tight, and my budget is very small to go do this. So I take every opportunity I can to go try to find the least affordable, the cheapest way, or cost-effective way to get some of these cubes on orbit for these universities. There are commercial entities out there that have commercial pricing. Spaceflight Services on their website, they show what it takes for 3U to low Earth orbit, to MEO orbit, or even escape. Those prices are pretty reasonable, what the marketplace is. When you go and procure a launch service of this type, we're probably expected to be greater than that. However, the benefits will be that we get to identify the exact orbit that the scientists want to put their spacecraft. So you may have to pay a little more for it, but yet you're going to get more benefits in the long run.
With a first flight, again, we're buying a demonstration here, so we're hoping to be one of the first payload customers as these companies finish their development and bring that commercial solution forward. We're willing to pay a little more for that first flight. We know it's going to be, a little bit more than what we're getting today in a rideshare agreement. But over time, we'd expect these costs to be driven down, and you'll still probably pay a premium for a dedicated orbit versus being in a rideshare situation. But we expect this to get competitive with the market that's out there commercially and being talked about for launching small satellites.
All right, next is Jeff Faust from Space News.
Great, thanks. I wondered if you could give me a little bit more detail on why the breakpoint mass is at 60 kilograms versus 50 kilograms or 100 kilograms or something like that, given I know there are a number of dedicated small-sat launch vehicles under development that are sort of in the 100 kilogram or so class. What makes 60 the sort of a special number here?
So we put out a very, and Jeff, you guys are aware, back in 2013 when we put the next requirement out there, we went out at 15 kilograms. So we tried to go really small. Again, cost being one of the biggest drivers when you're spending strategic investment money to try to make this happen. So we have seen through our market research that's probably too small, that we need to go a little larger than that to be able to match what the commercial market looks like and what our satellites internal to NASA, if they're to design this small, would look like. So we talked internally, 25 kilograms might be the right break point, and that was based on some future science we see and what potentially a future requirement would look like. There's a Cygnus mission that we awarded last year that's currently flying on a Pegasus It's 8 spacecraft, and if you were to break that up, they're all about 25 kilograms each. They're based off of, I think, a 3U configuration and then have grown a little bit off of that. So we looked at that as something that maybe we could model off of because there's a spacecraft being designed around it. We added a little extra weight because we are putting a requirement out there for the commercial provider to bring us their solution for launching these U-class payloads, because we, in fact, are buying what could look like a ride share for these satellites. So there's some kind of a design there, there's some kind of hardware there that would go around how the commercial provider would like to propose something that matches their commercial business case. So we wanted to put a little bit of math there. And then that gives you kind of the low end. And then again, we broke it at 60, just to try to make this not too complex. It's something that we thought, again, that wide net would give us the most amount of competition. Now, if somebody's got a solution that can launch more than that, that's, it's not precluding them. They can still meet the requirement, and the RFP doesn't, exclude them. Does that answer what you were looking at, Jeff?
Yeah, and if I could just briefly follow up, do you have a payload or payloads identified for this demonstration flight for this contract? Or if not, when would you do so, and what would be the process for selecting that demonstration payload?
This is Garrett. Well, we talked about earlier, I do have a list of CubeSats that has already been selected through the CubeSat Launch Initiative out of headquarters, and I do have the ones that are ready in 17 and 18 that will be candidates for this mission. I don't have the exact name for each one of them, but once we get closer, we get award, we start moving to the integration process, we'll select the ones that are identified that they will be ready in time for this mission, and we'll line those up to be the candidates.
Thanks. Thanks.
And now from Mick Wall at space.com.
Okay, hi guys. Thanks again for actually doing this. I just had a quick question about the timeline. So now there's like a draft RFP out, and like you anticipate a final one that's coming out in June. When do you think that the decision will be made? When will you award this contract, multiple contracts, to give people enough time to like sort of work toward the April 2018 launch date?
So typically on our larger spacecraft, we award at a L-30 window. That's about when we award a launch service. This being a smaller requirement is something we would hope in the future would be a quicker turnaround. As Garrett mentioned, with the different CubeSats that he has to select from, he doesn't need to make a decision until later on. We've tried to structure the VCLS contract to be very hands-off. We don't want the government to drive this design. We're trying to make sure we are not pushing and imposing too many requirements. So we have the intent to be fast, to be nimble. We are awarding early in this case. The plan is that we want to get the award out by the end of our government fiscal year. So that's by the end of September 2015 is where we would award the multiple contracts. The intent to have it so far in advance of the potential launch capability here is because it is a demonstration, and we've set up the milestones in this contract so that we can kind of shadow the commercial provider's development, attend their reviews kind of in a mentor capacity, and it gives us the time to understand this so that we can be a smarter buyer when there's a true science requirement that comes and potentially uses this if the demonstration is successful.
Thank you.
And now to see what got the name, Mike DeLune from Popular Mechanics, Bellevue from Popular Mechanics.
Hey there, thanks for taking my question. I wondered if you had any more details about what these vehicles might look like. I mean, do you foresee them being air-launched or vertical launched? I know someone else asked that, but it's also partly related to price, right? So do you have any thoughts about how low it should go? I mean, obviously if someone's launching at a greater cost than what's out there now, that wouldn't be very beneficial. So anything you'd like to say along those lines would be great. Thank you.
So we awarded the next contract in 2013 for just over $2 million for that 15-kilogram requirement. The capability of that launch vehicle was greater than the 15 kilograms, but just like here, we wanted to make sure we had some room for growth. I mean, designing these rockets is never easy. There's always things that happen along the way, and you need that margin there to make sure that the rocket's got a chance for success as they finish their development. We see options that are out there that are vertical launch. There's options out there that are air launch. There's options out there that launch off of a rail. So there's all kinds of things in the trade space, and we're definitely open. Again, we don't want to drive that design. We want to, again, buy something off the commercial market that's going to serve multiple needs.
All right, that is all the questions that we have. I'd like to ask Mark and Garrett if they have any concluding remarks that they would like to make, and make some points that might have come out in the briefings that we'd like to reemphasize.
So personally, I'm very excited about working this. This is a fun thing for us to try to help see a new capability come to market. And as our world is changing, again, the connectivity, the internet is something that evolved us. The explosion of the personal devices that we all have sitting on the table in front of us in our pocket is something that's empowered us. And having real-time satellite data in the future is something that's going to transform us and the way we communicate with each other. So this VCLS requirement that we're putting out is something that we're doing because we see this emerging commercial launch capability as something the world's going to need. We see commercial satellites that are on the edge of evolutionizing, changing the way we do business today. So we're just excited. We're glad you guys are out there asking these questions and helping us get the word out. We know a lot of these companies with their commercial solutions are relying on private investors to get behind them. They're all, like I said, they're all racing to be the first one to come to market. So we appreciate you helping get the word out there, and we're looking forward to communicating along the way.
Garrett?
Yeah, just real quick. I see that the U-class payload of CubeSats is not going away. This is a form factor that's being used by not just NASA, not universities, but other government agencies to do work in space and technologies. With this, when I first started working in the CubeSat world, we did our first mission on Glory about 5 years ago, nearly 5 years ago. Since that time, I have now seen students that worked on CubeSat project go into the workforce, and they're not going at entry level. These kids are going in as managers of organizations or developing their own companies. It's just amazing what we're seeing, the technology and the educational benefits of these cubes for the students today. This venture class is going to give us some more opportunities to fly more students, to get more students involved, and hopefully one day we'll get the students involved with the launch vehicle side of the house, where they'll start learning about propulsion systems and avionics on the vehicles, not just satellites, but learn this other aspect of it that's going to help the workforce in the other areas as well.
And it's funny, just looking back at the history, this whole requirement is us trying to be outside the box. So LSP started this strategic initiative because we had customers that were looking for more affordable ways to get to space from the traditional, $100 million launch cost. And they would talk to us because they had maybe $30 million, and they were trying to find a way to get to space. And we would look for ways to reduce our requirements, reduce the burden the government puts on them to see if we could get a cheaper ride. And we were doing the work in-house to try to find a way to enable that, but we just never had a customer come. Garrett came into my office one day looking to find a way to get these CubeSats into space. We started working together and found out, we've got the ability to demonstrate this. We've got payloads sitting around that are high-risk tolerant that we can use to burn down this backlog to help push this forward. So I think this is the right step.
Well, that will conclude our briefing on the RFP, request for proposal for venture class launch services from Launch Services Program. And we thank you very much for dialing in and listening. This concludes the briefing. Thanks very much.